Hi, I'm Mr. Akram, and this is a quick revision for Middle 1, Unit 1, Lesson 1, which is talking about proportion. So, what's the meaning of proportion? The proportion is an equality of two ratio, and its meaning equality of two ratio. It means we have a two ratio. All of us know, of course, that the ratio may be written as a fraction. So, consider we have maybe 2 over 5 and another ratio maybe 3 over 4, and we need to know if the two ratio has a relation proportion or not. So how to get it? First we need to as a fraction we need to use the cross. 2 times 4 and 3 times 5. So 2 times 4 equals 8 and 3 times 5 equals 15. So of course the two ratio are not equal and the relation aren't not proportion. So let's have another example. Now we have 1/5 and 7 over 35, and we need to figure out if the two fraction or two ratio has a proportion relation or not. So the first strategy, we need to use a cross. So 1 times 35 equals 35, and 7 times 5 equal 35. So now we have an equality, the two ratio are equal, so the relation between the two ratio are proportion. Okay, we have another solution. 1 over 5 and 7 over 35. So the numerator here is 1, so 1 become 7, so multiply the numerator by 7, and we need to also to multiply the denominator by 7, right? So 5 times 7 equals 35, and of course the denominator here is 35, so the relation is proportion and the two ratio are equal. Now let's figure out how the question. We have three type of question. The first one, to get the unknown. So here the given is two ratio like 2 over 7 equal. Equal, it means the two fraction has proportion and x over 5, and we need to get the value of x. And the other question is like a graph. The third, from the table, and also we need to figure out if the two relation proportion or not. So let's take the first example. State if the two ratio proportion or not. First example, we have 4 over 7 and 12 over 21. So first strategy to use the cross, 4 times 21 and 12 times 7. If the two ratio equal, so we have a proportion. The other strategy, 4 become 12. So we multiply the 4 by 3, right? So we need to multiply the denominator by 3. 7 times 3 equals 21, so the two ratio has an equality and the relation is proportion. The next example, we have 6 over 10 and 10 over 25. You can solve it by any strategy. So first strategy is 6 times 25, it's 125, so sorry, 150, and 10 by 10 equals 100. So 150 not equal, of course, 100, so the two ratio has not proportion. Okay, and you can use the next strategy, but you need to first to put 6 over 10 in the simplest form. So 6 over 10 in the simplest form, 6 and 10 has a multiple 2, the common multiple 2, so we need to divide it both of them by 2. 6 by 2, so 6 divided by 2 equals 3, and 10 divided by 2 equals 5, so the new fraction is 3 over 5, so 3 over 5 and 10 over 25. So 5 become 25, right? By multiply by 5. So we need to multiply the numerator by 5 also. But 3 times 5 equals 15, right? But the numerator here is 10, so the two ratio not equal and no proportion. So what about if we have the two ratio in this form? A to B to C to D. First, you can get it as a fraction. You can write it as a fraction like A, the same sequence, A over B and C over D, right? Or you can use mean and extreme. The mean here is اللي في الcenter is mean, and the outside it's called extreme. So A times D must be equal to B times C. Again, if we have the form A to B to C to D, not fraction, it's a ratio, and we need to get the proportion or not, we need first to multiply the extreme اللي في الطرفين A times B must be equal the mean اللي في center B times C. So if we have A times D equal B times C, so the two ratio are proportion. Okay, so اللي في center called means, outside equal or called extreme. State whether this sequence a proportion or not. 5, 8, 15, 24. First, by using mean and extreme, so we need to multiply 8 times 15, and if the answer equal to 5 times 24, so the two ratio are proportion, or you can write it as a fraction like 5 over 8, and the same sequence 15 over 24, not equal. Okay, first you need to check. So 5 become 15 by multiply by 3. So we need to multiply the denominator by 3. And 8 times 3 equals, of course, 24. So the two ratio are proportion and equality. Next example, you can pause the video and check the answer after you check. So 2 over 5, 2, 5, 4, 10, you can use means and extreme. So 5 times 4 equals 20, and 2 times 10 equals 20. So mean equal extreme, so the two ratio are equal and the relation is proportion. You can use it as a fraction, 2 over 5 and 4 over 10. 2 become 4 by multiplying by 2, and the denominator by 2 equals 10, so the two ratio are equal and the relation is proportion. One more, we have 3 over 4 equal x over 20. X is an unknown and we need to figure out the value, or the answer is to find the value of x. So the sign here is equal, so the two fraction has an equality and proportion, so you can use the property of proportion, which is 4 become 20. 4 become 20, yes, by multiply by what? 5. Excellent. So we need to multiply also the numerator by 5, and 3 times 5 equals 15, so x equal 15. Another example, we have 15 over x equal 30 over 12. The equal sign, it's mean, you can use the properties of proportion. So 15 over x equals 30 over 12. So 30 become 15. So we divided 30 by 2, right? So we need to divide the denominator by 2 also. And 12 divided by 2 equals 6. So the x equal 6. Another example, we have 1/3 equal 5 over x plus 2. The same way, the numerator become 5. 1 become 5, yes, by multiply by 5. So we need to multiply the denominator by 5. And 3 times 5 equals 15. So the denominator equals 15, and the denominator here is x plus 2. So x plus 2 equals 15, right? Using the inverse operation, the inverse operation of plus 2 is minus 2. So x will be equal 13. And you can solve it mentally. What number, if we adding to 2, equals 15? Maybe 10? 10 plus 2, it's equal 12, so it's wrong. Maybe 13, and 13 plus 2 equals 15, so the answer is 13, of course. And to figure out the proportion from the graph, we have a two conditions. The two condition is straight line and passing through the origin point. Again, to figure out the proportion from the graph or the coordinate plane, we have only two conditions. the relation or the graph must be a straight line and passing through the origin point. Okay, let's take an example. So in this graph or in this coordinate plane, let's figure out if the relation between x and y are proportional or not. So we have two conditions. The first is a straight line. So here the line is, of course, a straight line. This is a straight line. And the second is passing through the origin point. So the two conditions are satisfied. So this relation is a proportion. One more. Now we have a relation between x and y, and the first condition is satisfied. We have a straight line, of course, but of course it's not a proportion. Why? Because we have the second condition is passing through the origin point, and here it's intersect with the y-axis. So not passing the origin point, so of course it's not a proportion. One more. Now in this graph, the second condition is satisfied. We have the passing through the origin point, but it's a curve, it's not a straight line. So of course it's not a proportion also. One more, we have a relation between also x and y, and the relation here has a straight line, and the straight line passing through the origin point. So of course the relation is proportion. Now we have a table, and let's figure out if the relation between the two variables are proportional or not. First, you can solve it as a graph, and you can draw a graph like this, and here's x and y, 1 2 3 and 1 2 3, and make a line, and you can plot all the ordered pair 1 6 2 12 3 18, of course, and check if the graph maybe straight line passing through the origin point. If is it, it's a proportion. It's a curve or not passing through the origin point, it's not proportion, like we solve it. Okay, but if we need to solve it without plot the ordered pair, how to make it? First, we have relation between x and y, right? So the 1 become 6. 1 becomes 6 by multiply by 6, right? So this is called the constant of ratio or the rate of change. Again, it must be equal in the old table. Here we have 2. 2 become 12. It's of course 2 may be equals 12 by multiply by 6. Again 3 become 18 by 6. And 5 become 30 also by 6. So the constant ratio here is multiplied by 6. So the constant here is 6. Of course, the table is a proportion. One more table. So we need to figure out if the relation between A for Akram and R for anything. And we have the ordered pair. Of course, you can plot the ordered pair in a graph and check if the straight line passing through the origin point or not, of course. And you can solve it quickly from the table without graph. Of course, now we have 2 and 4. 2 become 4 with multiply by 2. So the constant here is multiplied by 2. 4 become 8. It's also multiplied by 2. 6, 12 by 2. And 10 become 20 also by 2. So the constant of ratio here in the old table is multiplied by 2. It's the same in the old table, so the relation is proportion. One more. Now we have the relation between F for Farida and Y for Yara. We have the ordered pair 1, 5, 2, 10, 3, 15, 4, 25. And we need to figure out if the relation between two persons are proportion or not. So 1 become 5. Of course, 1 equals 5 if you multiply by 5. And 2 become 10. Of course, it 2 become 10 if you multiply by 5. And the 3 become 15, of course, if you multiply by 5. Someone can call this table is a proportion, and it's not. Why? Because you need to check all the table. Now we have 4 and 25. And of course, 4 doesn't equal 25 by multiplied by anything. So it's not proportion. Why? Because the constant here in the whole table, it's not plus 5, or sorry, times 5. So this table, it's not a proportion. And if you graph it, you can graph it like this. And the first point maybe here, and here, and here. So it's a curve, not a straight line. So it's not a proportion. Now let's solve a story problem. Habiba take 5 hours to complete 4 assignment. Find the time taken to complete 3 assignment. First, the relation here is between two something. The first is the time, which represented by hour, and for assignment. Okay, so I have H and A for assignment and make a fraction. 5 hour and for assignment equal. Of course, the numerator must be H and the denominator is A. Okay, so the numerator here H, the numerator here H, hour and hour, and the denominator assignment and here assignment. You can inverse this relation. Yeah, you can make it as A and the H down, but it must be inversely here also, A and H. Okay, let's back. So Habiba takes 5 hours to complete 4 assignment. This is the first ratio or the first fraction. Find the time. We need to find the time. The time it's hour taken by to complete 4 assignment. Sorry, 3 assignments. So the assignment is the denominator C. So we need to write the 3 in the denominator. Okay, and you can take it like x. It's unknown, and how to make the x. 3 times 5 cross divided by 4. You can use the calculator. 5 times 3 divided by 4, and the answer decimal. Ron takes 30 minutes to walk a distance of 1,800 meters. Find the time taken by Ron to walk a distance of 3,000 meters. So the relation here between also the time and the distance. The time represented by minutes and the distance represented by meter. So we have minute and meter. You can inverse it. You can write it as meter and minute. Doesn't matter. Okay? So we have minute and meter fraction. The minute is 30. 30 minutes to walk a distance 1,800 meter. Again, make a fraction. The numerator minute and denominator is meter. So find the time. We need to find the time taken by a distance 3,000 meter. The meter is the denominator, so we need to write it as a denominator 3,000. And now we need to find the time here. To find it, you can multiply 330 multiplied by 3,000 divided by 1,800, like 30 times 3,000 over 1,800 cross, and you can find the answer easily. And that's it. We finished today.